All right, the Tao of extensibility. What are we going to talk about today? The idea is that as identity professionals, when we create product, when we devise, advise topologies and similar, we typically work on ideal scenarios. We look at the platonic ideal of some scenario, we control for every variable, and we distill to the essence the topology and the security characteristic of a particular scenario. And then we typically create products that implement those canonical scenarios, which is all good and fine up to the point in which you take these products and you try to apply them to your own real world scenario. And sometimes you'll be lucky and you'll be able to use the out-of-the-box features as is. Some other times it will turn out that there are some important differences with what you actually have in your scenario that prevent you from using the product as is. And so the idea is that pretty much every product have some strategy for coping with this situation. And that strategy is typically some form of extensibility. And very often people have just their own custom approaches, and it's difficult for you to compare different approaches, different strategies, the effectiveness, the trade-offs. So this session is meant to shine a light on that and give you some kind of taxonomy, some kind of criteria for understanding how to compare those different approaches, and most importantly, pick the one that works best for your scenario. So here is how I'm going to break things down. First, I'm going to cover high level what is the ideal condition, like what is the situation in which if there is no friction, no gravity of the moon, no tides, you can work on your pure problem and there is no oddity, like your scenario is exactly a quintessentially typical scenario, then what normally our product as identity products, not just of zeros, are meant to solve. And then we'll see just a hint of the places where those kind of assumptions usually break down, like where usually you have a difference in that respect. Then we are going to analyze the different ways in which products can bake in some margin, some impedance mismatch management that will allow you to use that product even in conditions that are not perfectly ideal. And we'll see that different approaches have different characteristics, different costs, different expressive power. And then I'll probably run out of time before that, but we'll just take a high-level look at scenarios that often break down, as in like situations where exactly you find yourself having to use those extensibility points in order to address your problem. Okay, unfortunately, I don't have a lot of feedback, so I cannot see if you guys are already falling asleep or if you are still on board, if the agenda works for you. I'll just be optimistic and assume that it works for you and go ahead with that. So let's first talk about the ideal conditions. And let me actually pop out of this and create a bit more movement. Now, what I'm going to show you here is something that all of you are probably familiar with. And it's just typically how you approach one of the most classical scenarios in this space, which is how to deal with with the fact that you have an existing identity system and you want to centralize it. This is one of the most typical uses of identity product. And so that's why I picked it as the scenario that we'll use as the baseline. So imagine that you have a classic scenario in which you have a legacy application, which deals with identity on its own. So the way in which this would normally happen is that you have a user which uses the browser to land to your application. Your application deals with identity on its own, so contains logic for prompting the user, for validating credentials and similar. And so the user ends up taking their credentials, sending them to the app. The app will have logic that compares it to some local credential store. And then if everything works as expected, it will create a cookie which represents your successful session. And then from now on, the user will just hit your web application using that cookie. That is the starting point of countless identity projects. Now, in an ideal condition, what would happen is that you'd want to centralize that function. Now, you can centralize these in many, many different ways. And in particular here, I'm going to bring one central authority, which matches with my sponsor here, which is of 0. But from the architectural perspective, this is something that you can do with any product. Any product that supports a modern identity, so SAML, which is not so modern, but still more modern than this, OpenID Connect, any system that you want to use and where you want to centralize, you can introduce it in the system. You can take your existing identity support. So here I'm moving the credential store, but in fact, you can think of these as also all the logic that was inside the app for gathering and verifying credentials. You can now place a facade in front of both your central authority and your application. This facade can be an SDK, can be middleware, can be an API gateway, anything that supports the protocol that you want to use for outsourcing authentication. And now your new flow goes as follows. Your user attempts to get a page on your web application. Your middleware intercepts the request, formats an authentication request according to the protocol that you want to use, redirects the user to your identity provider, and this time the user plays credentials against this central location. And if everything goes well, you get an intermediate artifact, a token, and then this token gets sent to the application. The same middleware that triggered the dance for authenticating on your central location will validate the token. And if the token is fine, you just get your cookie. And at this point, you successfully centralize authentication. And now there is the cascade of all the usual advantages that you can expect, like a central place in which you can manage authentication for multiple apps, not just one. You can have a central place where you can turn on things like consent management, multi-factor auth, all these things that you are familiar with and that I will not touch on today. Now that's the ideal situation, but unfortunately, this ideal situation doesn't often happen. In fact, there are a number of things that we are assuming will go well in order for us to apply the approach that I just described. In particular, here you have seen me doing this very easy motion, which I grabbed the user store and I just moved it in a central location. In the real world, that might not be all that trivial. Let's say that user store might be certified. For example, if you are in an industry with a high risk, then you might have had to certify the place where you are saving your users and the way in which people access it. And just grabbing that store and moving it elsewhere, especially off-premise, might be a challenge. Or you might have, hopefully, credentials that are hashed. And so when you move it up in the cloud, if you don't have special features, you might force your users to change your password, which might be unacceptable. Or if one of the advantages of centralizing location of authentication is that you want to also talk to external identity providers, as it is very often the case, other directories from other companies, social providers, any source. Now, depending on the technology that you picked for doing your central authentication location, you might or might not be able to connect to those identity providers out of the box. And so you might need to provide some kind of, how to say, extra logic, extra integration glue in order to connect there. Other things might be the authentication out of the box. When you have seen me moving the authentication capability from inside the app to the central location, I made a very strong assumption, which is that the application was only doing authentication in the initial phase. And very often is not the case. Very often applications integrate extra capabilities in that phase. So for example, you might have a subscription management system which verifies whether your user paid their dues. So not only you are checking their credentials and you are dropping cookies, all the things that I described, but you might have custom code that you need to run in the context of authentication. If you take a product that out of the box does just authentication, then you will not have a one-to-one mapping between what you had before migration and now that you migrated. And this thing might work for you, or you might have a problem. This might be a blocker for your approach. Or you might have all sorts of other things. Like I remember a customer that didn't want just username and password, but they wanted username and password and some kind of tax field, like a second username. If you get something that just gives you the classic username and password out of the box, or even more advanced features like MFA, WebAuthn, and similar, if you have a third field to add, no product out of the box will offer that. So either the product offers you some wiggle room for adding this capability, or you are out of luck. And then I'm just mentioning this out of completeness, but every application, every solution has its own logic for authorizing. And you might be lucky, and you might be in a system in which classic airbag might work for you. So you might have a very clear-cut roles, you might have very clear-cut permissions and resources definitions, and so you can use out-of-the-box capabilities that come with many platforms for dealing with authorization. But more often than not, your resources will have complex logic behind that. Like, for example, you might be in countries where people cannot work in the weekend. Or if they work in the weekend, you must certify that you are not forcing them to, but they are choosing it. So how do you integrate the need for working only a certain times of a day or certain days of a week when you only have out-of-the-box role management? Or think spending limits, like something which tells you whether the user can spend a certain amount of money. How do you integrate that kind of check in your system? Out of the box, it's hard to have something which is already just a checkbox for this kind of really peculiar kind of check. So those are all things that might not work out of the box and that you might need to solve in your identity project. Now, how do you typically do that? The idea is that pretty much every product have some wiggle room, something that you can use for adapting the product to your particular scenario. But now the question is, how much of that expressive power do you need for your scenario? And how hard is it going to be for you to actually take advantage of this extensibility? In my experience, everyone has very different approaches, but I've never seen a visualization which places all of those approaches in the same space so that you can compare them. So I tried to create one, and that's what you're going to see here. Here you have this quadrant, which has two main dimensions. On the x-axis, we have the difficulty that is inherent to that approach for implementing. So in particular, it is how easily do I get this solution up and running? How much knowledge I need to provide out of band for using this? And what's the total cost of ownership? Do I need to worry about this thing all the time? Or once I set it up, will it just run itself? So no problem. So here, the more you go on the left, the harder it is, the more it's a burden on you. The righter you go, the easiest time you'll have taking advantage of that particular approach. On the y-axis, we have the expressive power. At the very top, we have no customization whatsoever. That's to say that the solution that you get has no flexibility. You cannot change anything. Either it works for you or you've got to buy something else. On the opposite side, on the bottom, you have like the lowest level access, which means complete control. You can do whatever you want. There is no limitation. If a Turing machine can do it, you can do it. So let's place in this space some well-known strategies that products implement. And we start at the absolute bottom, and we start with coding from scratch. Now, coding from scratch is a possibility. I'm sure that if you work in this industry, you had your share of people saying, my scenario is such a snowflake that I absolutely cannot use anything out of the box. I've got to write everything from scratch. In my experience, there are two main categories that fall into this kind of strategy. One is public administration, so military and similar, so really proprietary technologies with real-time requirements, like things that are really, really extreme, in which case it's justified for them to do something from scratch. The other category is academia. Academia is this special place in the universe where laws of physics are suspended, in which you can get really qualified workforce at next to no cost. Because if you are your postgrad that just wants to get his or her diploma, they'll work for you for free and they are really advanced. So that is the scenario where you can actually afford to have someone write something completely from scratch. Of course, you have complete control, no constraints whatsoever, but that is also nearly impossible to pull off. Like writing an identity system completely from scratch is extraordinarily hard. The next step in this journey is using an SDK. Identity has a large number of repeated actions, a large number of basic building blocks and primitives, messages formatted for a particular protocol, crypto, like the ability to parse a certain token format and check the signature, mechanisms for acquiring metadata and the rotating keys. Those are all things that won't be different across solutions. And the main difference is going to be the platform that you use. So if you are on Node, or if you are on Java, or if you are in .NET, those would be constraints that you want to use, but ultimately how you check a signature won't make much of a difference in your system. And for you to rewrite that code is reinventing the wheel and taking a huge risk at the same time, because those are mission critical security operations. And if you do something wrong, the consequences might be catastrophic. So using an SDK that already takes care of those building blocks is a huge help in terms of complexity. So it's way easier for you to implement a system if you start from an SDK. However, you still have a price to pay, which is you own writing the central place. You need to write a service which listens to requests, that is up, that possibly can scale horizontally and vertically, and is manageable, that is protected by the various classic attacks. So it's still an important burden. You still have a lot of freedom. You can build this thing in whatever way you want, but you don't have as much freedom as writing from scratch. So for example, say that you want to use elliptic curves for checking signatures. Your SDK does not support them out of the box. You have to write something on your own. So you don't have as much freedom as writing everything from scratch, but it's a huge help. But at the same time, it's still requesting a lot of work on your side. Now, the next step in this quadrant is using a product that comes out of the box. So instead of using something that you include in your coding, in your like custom application, think about a product. I don't want to mention any specific product, but something that you install. So classic old school server that you would run on an actual machine or a virtualized machine, or a server role in some particular operating system, something that implements some identity scenarios like web sign-on, API calls, OAuth, OpenID Connect, SAML, and that comes as a product. At that point, given that it's a product, there are many things that are already figured out. So the management, the surface, the endpoints that are exposed, the way in which you deal with clusters and similar, all of that comes out of the box. So in terms of ease of implementation, that's much easier. In terms of expressive power, though, not as much. So you own that instance, so you have complete control over how that instance is initialized. However, you are bound by the set of scenarios that the product designer decided to support. And so you still have a lot of freedom, but the dimension along which you have this freedom is more about configuration. And that is also something that leads to one meta consideration here. All the approaches that I described can only get so far in terms of ease of implementation, because all the approaches that you described so far postulate the fact that you run it on some hardware, be it actual iron or virtualized. That's something that you are running. And so no matter how easy the product becomes, you still have to pay the price of running something yourself. So I'm sure that in the last 10 years, you had marketing departments touting the advantage of platform as a service versus infrastructure as a service. Well, here we are decidedly still in the infrastructure as a service side, in which you are still responsible to patch the machines on which you are running this stuff, in which you are still responsible to decide how many instances this thing is running on. You have to decide the regions where those machines are being instantiated. So there is a management burden that is intrinsic to this approach. Now let's go in the polar opposite direction here. And let's consider instead something which is super easy to implement, but also completely inflexible. Imagine that the problem you're trying to solve is not a generic identity, but it's a specific task that just happens to require identity. So imagine that you are trying to solve the expense note task for your company, or travel booking, any of these quintessential SaaS workloads. And so at that point, you can pick one application that is already performing that particular function, and then you have to leverage whatever identity features that application offers out of the box. And they might have multiple identity providers, they might have ways of connecting to your own source of truth and similar, but in general, the idea is they are very constrained. They are not a platform for dealing with identity as a general purpose functionality. So you get what you pay for, as in they'll give you the functionality that you want, and there is no cost in terms of running the service apart from buying the subscription, but it's super easy to run. But at the same time, you have very little latitude. Now, the next step for this is to turn the functionality that you get from a SaaS vendor on its head, and now getting identity as the very functionality that you are getting. At that point, you are still using something which is very easy to implement, typically, because it's a service. Well, easier than the ones that we described so far. Then there are always challenges. But if you have a SaaS provider that provides you with identity capabilities, at that point, you have something which is easy to implement. It's a service, but it also gives you more flexibility than a SaaS app. So typically, you'll have more choices about the identity flows that you want to use. You'll have more choices about the resources that you are protecting. So the SaaS app will protect itself. The IDaaS system will give you a general purpose authentication system for your own resources or for other apps that you're pulling in. But here there is another consideration to be made, this time not for implementation, but for expressive power. The idea is the way in which you extend IDaaS, and extend here might not be the right word, the way in which you customize your instance of your IDaaS can be approached in many different ways. And on the top of the Maslow pyramid, there is checkboxes. Like say, I want to sign in with Google, I want to sign in with Facebook. And potentially those things are literally just checkboxes. Or I want to use my custom domain. There, it will be a text box where you enter your custom domain and you check how it goes. Or I want to enable this particular auth grant, but I want to disable all the other ones. Or I want to use only this kind of credentials rather than this other. All those kind of extensions can be achieved by using point-and-click UI. However, there is an entire class of extensions that cannot be achieved just for that. Think of some of the scenarios that I described earlier. Like say that you want to also deal with subscription management at authentication time. No amount of checkboxes will allow you to do that. And that's why the next step in the evolution of IDaaS is the ability to actually use code. So not code in the same way in which we have seen in the coding from scratch, in which the developer takes the burden of dealing with absolutely everything, including the essentials of authentication. Not in the way in which you would have done it with identity provider SDKs, in which you have to deal with availability, you have to deal with anomaly detection, security, or like a prevention of denial of service, all of those things. No, here in IDaaS plus code, in there you can expect all the essentials to be taken care of, so that if you don't need any extensibility, anything that delves from the default, you just rely on the out-of-the-box offering and you are fine. You solved your problem. But if instead you want to inject your own code, your own logic in the pipeline, such as, for example, something that picks up a custom parameter in your request and compare that parameter to your database of subscription management and tells a yes, no as the context of authentication, well, that's something that you cannot achieve without code. And if you have a platform that allows you to inject just in the last mile that particular piece of code, then you'll have the best of both worlds. You'll have all the essentials taken care of, especially the mission critical ones about security, and you'll have enough expressive power to do whatever you want in that space. And of course, needless to say, Auth0 has been championing IDaaS plus code. I think we were the first on the market to do that, and now a number of different companies offer that. But I'm very passionate about this because to me, it's the Graal. Let's say that we can take care of the essentials without anyone having to reinvent the wheel and do dangerous stuff like their own crypto, but at the same time, you retain complete freedom. So that's the landscape. And I tried also to touch on the various trade-offs. Let's say that that doesn't mean that IDaaS plus code will always be the solution that you need. Again, if you are doing something on which is not always connected, you might need to do something heavily customized. You might not be able to rely on a cloud service. But hopefully I made clear when it's the case to take advantage of that particular approach and what are the costs that you can expect versus what are the options when instead you are in a slightly less custom scenario. Yep, I already made this point. So here, let me just make some of the discussion about IDaaS plus code a bit more concrete. Now, what you see in here, it's the bare-bone version of an identity as a service system. And what you're seeing here in particular is the journey of a request that goes from a particular application through your centralized authentication system back to the artifact that you are sending back to your resource or your application. In other words, it's what happens inside the authentication system that you use for centralizing your location. And what you have in here is the absolute basics. Let's say that in the bare-bone system, you can expect some UI, which will pop up at the time in which you want to authenticate. And this UI will either gather credentials directly for a system that supports like a user store, or show some kind of home run discovery for connecting to different identity providers. But from a high-level perspective is, I have an authentication prompt and possibly a credential prompt. The next step, once you authenticate it, is to access profile data. Every scenario will have either attributes of a user that are saved directly and stored in there, or something that merges what you got from external identity providers in terms of claims and attributes and what you have locally. So here you will have some system for enriching and creating the profile of your users. And the outcome of this will be artifacts as described by the protocols that I mentioned earlier that will help you to prove to your target application that successful authentication occurred. Now, out of the box, if you don't want to do any customizations or simple customizations, this is all you need. But now brace for the next step. What you're seeing here is an enriched version of that flow where particular stages are interleaved with meaningful extension points. In other words, we analyzed what people do when they are trying to customize their application, their authentication flow, and we identified the places where it is likely that the developers will want to inject custom code. And now, this thing looks very complicated, and it is, but the good news is that very rarely you'll have to be aware of all these moving parts. Depending on the scenario that you're trying to achieve, you'll end up focusing on specific parts. So just to give you a super quick overview of these. The idea is that, as I mentioned earlier, the first thing that your request will encounter is some kind of user experience. Behind the scenes of a user experience here, you'll have some kind of automated mechanism for doing continuous authentication or assess the context and realize whether what you're receiving is a possible attack. So there are different things that the services can check in the incoming request for classifying whether the current request is likely to be legitimate or if it's something that requires extra scrutiny. And this is one place that you will usually get out of the box, but it's one place where you can expect some kind of extensibility. Such as, for example, in Auth0, we have our own engine for determining whether IPs are trustworthy or if instead the IP comes from a machine which is known to have been compromised, so part of a bot and similar. And not only we use that capability in our own checks out of the box, but we also expose it as an API. So if a different solution wants to leverage that signal, they can. So that's one example of programmability. The other thing that you can get at this stage is one of the most important things that you can do, which is integrating with identity providers. And here you have either the super easy case in which you have your own source, which comes out of the box with the system, or you might connect to a number of different identity providers, and depending on the system that you're using, you'll have a different selection of out-of-box integrations. And then you'll have meta integrations, such as, for example, all you know about a provider is that they support SAML or OpenID Connect or OAuth plus an API for users. And then at that point, you can inject some code in there to actually, for those cases, you don't need code. You just, for OpenID Connect and SAML, you can just select the metadata of your source. And so it's still a click-through extension with doesn't require code. But if, for example, you want to connect to OAuth, you have to. You have to add some code because OAuth just gives you opaque tokens, which you cannot look at. Like those tokens are meant to do delegated authorization. So if you want to turn OAuth into an identity authentication flow, you need to actually use the access tokens that you obtain to call APIs that are capable of giving you user information. That's the only way in which you can securely turn OAuth into a sign-in flow. And if your system doesn't allow you to inject the code for making that call to that particular user info, then you can't really securely leverage identity sources. So a place where having code in the pipeline really helps. Another place where code really helps is in the case in which you want to connect to a database, which doesn't have the ability to move. Say that you have a database somewhere and you cannot move it as is. But you want to loop that in the context of your request. In the particular case of Auth0, it's just one example of code-based extensibility. You can actually provide to Auth0 a couple of scripts that will reach out to your database programmatically, and it will use whatever mechanism you are using for authenticating, be it a connection string, username and password, anything that your database requires, and will extract user information on the fly. So that from the point of view of a resource, this flow will still be a standard flow, but in the middle of this flow, we will just inject the ability to reach out to your database and integrate it, so that even in the cases in which you cannot move the database, so one of the cases where the, I'd say, basic assumptions go sideways, let's say that you cannot do something that the canonical scenario would require you to do, here you can actually loop in this kind of scenarios. And on top of this, just as an aside, you can also use these for just-in-time migration, so that when a user signs in and you send them to the local database, upon successful authentication, you can actually recreate an entry for that user in your own database. And so basically the users migrate themselves. That's another thing that you can do if you have the ability to inject code in this particular place. Let me accelerate a bit because I want to give time for questions. Just for mentioning and passing other things that you can do in here. Here in this particular case, we identified events before and after user sign up. Imagine that you want to sign up users in your application only if they are using their work account or their school account. You don't want Gmail or Hotmail or Yahoo Mail accounts. Here, you have the ability to inject code that at sign up time, verify the shape of the email that your user provided and apply whatever logic you want. Or afterwards, if someone signed up and you need to run extra logic afterwards, like imagine you are an airline and the user that signs up already is a frequent flyer with you, but simply they don't have a user in your website. Now in your post sign up, you can reconcile everything you already know about that particular person and connect it to the account just being created. So those are just examples of sign up. And then in general, here we have like the most generic mechanism for extensibility, which in the case of Auth0 are called rules. And the idea is that in here, you can inject any Node.js logic, including logic that uses external SDKs, and you can manipulate the temporary, intermediate artifacts that you are about to send out, like access tokens, ID tokens, and similar, and you can add elements, you can subtract elements, you can change anything you want in there. You can have anything like updating external APIs, and you can even show extra UI. So this is the place where you would inject the code for dealing, for example, with custom subscriptions and similar. And if your logic requires showing a UI, imagine that this call is for accessing a confidential document. And imagine that you want to make sure that the user already signed an NDA before they sign in. Without the ability to do these extensions, you might need to have an external app that lets them sign, and then you ask them to come back to your app. In here, you can inline everything. Let's say that imagine you integrate with DocuSign, and in your rules, you check whether the current user signed a particular document using the DocuSign APIs from here. If they didn't, you can actually redirect them to DocuSign, have them do whatever they need to do, and then the flow simply sends them back in here where you can run the rule again, now see that they correctly signed, and then just let them go through with their authentication. And at this point, if you do this, you have the ability of doing this for every platform, like mobile, web, Apple TV, anything, literally, just by the virtual fact that this is running inline inside your authentication flow, which is really powerful. And then, of course, here you have other places like multi-factor authentication. You might want to modify it, or user consent, again, a place where people might want to modify stuff. So here, I just wanted to give you a feeling of what it means to provide an IDaaS plus code. It's the same capabilities that I mentioned earlier, plus injected the places where you can add the last mile integrations and just do the bare minimum for cover your particular scenario, as opposed to having to bear the burden of doing things like, for example, checking the signatures of those tokens and similar. And in the interest of time, I described those scenarios while we were talking about the pipeline. And so now we can happily skip all of that and go straight to our conclusion, which is, although it's legitimate for us identity professionals to simplify things when we are devising patterns, high-level scenarios, threat models, and similar, reality is that those idealized scenarios will rarely apply as is in real-world situations. And the idea is that you have seen there is a gamut of approaches that you can use, which goes from you take complete control of absolutely everything to you take something which is completely defined out of the box. And hopefully I gave you a sense of how nicely IDaaS plus code hit this happy middle in which you don't have to compromise on security because it's coming out of the box, but you also don't have to compromise on expressive power because you have all the places where you can inject your code at any time. But in any case, that is just like a general approach. Then what works for your scenario, you be the judge of that. Let's say that now you have this range of approaches, you know what products map to each approach, and hopefully you are empowered to pick the right decision. And on that note, I think I'll just catch my breath and open up for questions.
Perfect. We do have a couple of questions in queue. The first one is from Ernst, and it is, one common challenge for us is migrating APIs, which had been based on user credentials to key-based authentication. What is the reasonable pathway to pivot from user creds to key-based?
Very good question. Thank you. The main thing I'd mention is that very often the opposite flow occurs. Let's say that people start with keys because they are an easy way to deal with access, and then they go in the opposite direction. And so at that point, when you move to user-based, you can have like a intermediate stage in which you send both. In here, I'd say that we should probably double click, and we can do it offline, on the particular scenario. As in, depending on what you were doing before, the user credentials might or might not reflect the way in which you assign the privileges. So if you have an API, and this API is a facade to resources, imagine it's an API for reading documents. And then you have individual documents, and each document knows who can do what. Like this user can be a commenter, can be a writer, can be a viewer. And if now your system is based on username and password, and you assign privileges per user, if now you move to the keys, then those keys need to be one per user. So rather than a key, this sounds a bit like when you create app-based passwords for applications that cannot do MFA. So imagine that you are like on the iOS client. You want to use the mail. Your mail provider needs MFA, but the client on iOS cannot do it. Then often you can actually go on your provider, you can create one password, which is just for that app, for that device, for that user, and then you integrate it back in there. So but if you are in that situation in which the user is the highest order bit for assigning privileges, you might need to do that. And then at that point, depending on the system that you're using, you might need to create client credentials, which are just keys assigned to the app. And then you just distribute those keys. Again, I would recommend that we have a sync up out of band because it really is complicated. Because the moment in which you move to key-based system, now you suddenly have a problem of distributing those keys. And you have a problem of maintaining the life cycle of those keys. And so, although from the protocol perspective, it's very easy to set up, it's one of the easiest flows that you can set. In terms of management, in terms of setup, these might be very challenging. So if you want, you can just hit me on Twitter, on email. I'm happy to help.
Okay, perfect. Second question is from Dev, and I don't know if I'm going to pronounce this right, but what is the integration with Apigee API gateway, as we are using this for our enterprise services using OAuth 2 token?
Now, integration should be pretty easy. in particular, from if you are looking at integrating Auth0 uses JWT for every format, for every token type. Apart from the tokens from our own user info, every other token we produce is a JWT. And so you can just configure your API gateway with the metadata of our authorization server so that it knows what keys should be used for validating tokens. And then you just accept JWT tokens and your gateway can convert them. So that's the typical way in which API gateways get integrated with Auth0 or similar services. As a side note, OAuth out of the box says that access tokens are opaque and they have no format. And this has created a number of issues because a lot of providers, not just Auth0, use JWT as a format because it just makes sense. When you have an authorization server which is not co-located with your resources, you need a way of validating those tokens without shared memory, and using introspection is very expensive. So a lot of people in the industry use JWT as access tokens. There is a draft of a new specification that extends OAuth and specifies how to use JWT for expressing access tokens. And I happen to be the author of that particular specification, but it's an official ITF draft. So it contains the contribution of people from every company, Ping Identity, Amazon, AWS, everyone commented and contributed. So if you are interested in API gateways, I highly recommend you check out that draft.
It looks like that'll do it for the questions for today. Thank you so much, Vittorio, for joining us and for talking about extensibility.
Thank you for having me.
Yeah, thank you so much. This is Christine again with IDM Works. I just wanted to let all the attendees know we have more sessions coming up in July and August to round out our summer IAM Pro series. Next up, we'll have sessions covering consumer IAM as well as identity governance. So we hope that you can join us next month. And in the meantime, everyone take care.